Welcome to Fossils and Fiction, a podcast exploring cultural and scientific ideas about dinosaurs. I'm Travis Holland. In this episode of Fossils and Fiction, it's the first in a new format that I'm calling the Research Journal. It features detailed discussion of two recent publications with two PhD candidates. Isaac Kerr from Flinders University joins me for a chat about his work on a new genus of kangaroo from the late Pleistocene of Papua New Guinea, and Adele Pentland from Swinburne University and the Australian Age of Dinosaurs Museum is here to discuss the osteology of Ferrodraco lentoni, an anhangurid pterosaur from mid-Cretaceous Australia. Of course, neither the kangaroo nor the pterosaur are specifically dinosaurs, but so far as I'm concerned, big, dead, and in the ground is just as good. Welcome.
My name is Adele Pentland and I'm a PhD candidate at Swinburne University of Technology in Melbourne and Honorary Research Associate at the Australian Age of Dinosaurs Natural History Museum.
Adele, I wanted to have a chat about your new paper, The Osteology of Ferrodraco lentoni, which is one of the most well-known or the most well-known Australian pterosaurs. Tell us about what you found in this 2022 paper.
This more recent paper was an opportunity to try and describe as much of the skeleton in as much detail as possible. And then I also wanted to try and do a phylogenetic analysis. Even though we did one previously in the 2019 paper, I wanted to contrast the results and use a different data matrix and see how that impacted the results.
What did the new analysis show?
So the position of Ferrodraco didn't change that much. So it is still coming out as the sister taxon to Mafunga camara. So Mafunga is the first pterosaur species that was named from Australia in 2007. And it's a little bit older than Ferrodraco. So that kind of makes sense that you would have these two Australian taxa together. But then this more recent analysis demonstrated that they are more closely related to two other Gondwanan pterosaurs, so Tropignathus mesembrinus and Sauropteryx moracensis. So I should explain that Gondwana is the big supercontinent that included Australia as well as New Zealand, New Caledonia, Antarctica, India, Madagascar, and South America and Africa. So what these results are showing is that our two Australian taxa are closely related to one species from South America and one species from Africa, which sort of makes sense. We see this pattern in terms of the diversity of dinosaurs as well and other groups. But this does differ from the 2019 analysis because in that paper I showed that Ferrodraco was closely related to ornithocheirid, which is actually from England. But in the 2022 paper, ornithocheirid is sort of popping out of the phylogenetic analysis very early on. So it's sort of demonstrating that it's more basal in this matrix, but that is probably because ornithocheirid is just the very tip of a snout. So we sort of see this happen more generally in not just the phylogenetic analyses of pterosaurs, but all kinds of things. If you don't have a lot of information, anatomical structure to describe, or if something is being misinterpreted, say if you have interpreted what is actually a lizard as a small dinosaur, then it'll pop out early in the phylogenetic analysis. So yeah, just some very different analyses. I'll probably continue to rescore and add Ferrodraco into more phylogenetic analyses in the future and just try and refine it.
We should have just a little bit more background on Ferrodraco. As I understand, the name means iron lizard. Is that correct?
Iron dragon.
Iron dragon,
Yeah.
Of course. Draco.
Okay. Yeah. No, I had the privilege of naming that one. Yeah, it was me. Yeah. We had picked a nickname for the individual. So that was nicknamed Butch after Butch Lenton, who was the previous mayor of Winton. Winton being the town near where Ferrodraco was found. I wanted to name the species after Butch Lenton, so that's why it's lentoni. And yeah, I wanted to have a name that was easy for kids to say. So I had a bunch of different combinations of words in an Excel spreadsheet, and then I came up with Ferrodraco. And then later found out it's like a boss in Minecraft, which I had no idea about because I'm too old for Minecraft.
Can you explain the scanning process that the fossils underwent at the synchrotron?
We took the specimen down to the synchrotron at near Monash close to Melbourne if you're not familiar with this part of Australia. And the synchrotron is a big round building and it's a particle accelerator. So it's shaped like a donut because it needs to accelerate particles and then those are projected at whatever object you're studying. So at the time that I took Ferrodraco down for scans, they were also studying clay tablets, archaeological artifacts. It could be used for all sorts of things. It has medical applications. So a cool upshot of that is that we can use it to study the internal structure of fossil material, of bones. Unfortunately, a weird thing happened when we had the synchrotron scans done. So the shape of the teeth of Ferrodraco are just the perfect size that they actually focused the laser beam that was being projected at it and it scratched the sensor, which was really bizarre. And I thought in a bit of a panic when Dr. Joseph Bevitt, who's a co-author on the paper, when he told me that happened, I thought, it was going to hold the process up for hours, which cost thousands of dollars. It was just like a little scratch on the sensor. The process of getting anything scanned at the synchrotron, it's a pretty competitive process because they're high resolution. It's a big drama when you damage the sensor or something needs to be replaced or fixed with it, as I understand it.
In the conclusion, you mentioned that there are some indications of diversity of pterosaurs, even though we've only really got a handful at the moment.
Paleontologists sometimes get made fun of because the conclusion of basically every paper is we need more fossils to study and sort of get a better picture of things. But as we sort of demonstrated with this specimen, the discovery of one fossil can really change and shed light on our understanding of these ancient ecosystems. So the hope is that if we find more examples, then we can possibly see how there might be individual variation or get a better understanding to see, is there more than one species of pterosaur present in this particular geologic formation? And then if we're looking at stuff, that's tens of millions of years apart or a few million years apart, can we possibly prove that one species is directly evolving into the other? But that's normally very difficult to demonstrate.
Isaac, tell me about your paper, A New Genus of Kangaroo from the Late Pleistocene of Papua New Guinea.
Yeah, so what we've essentially done is we've had a look during my PhD, which is on the systematics and paleobiology of an extinct genus of kangaroo called Protectrodon. We re-examined the identity of some fossils that were found in the 70s in New Guinea from a place called Nombi Rock Shelter. And the species was called Protectrodon nombi by Tim Flannery in his study in the early 80s. We had a good look at that set of fossils and compared them to the rest of Protectodon. And basically they weren't fitting. They had quite different teeth. And, when you've just got sort of two jaws to go off, which is what we had for this species, the teeth are very important. So we saw, okay, this isn't a Protectodon, so what is it? And we looked at every other kangaroo that we could find, and, it wasn't really fitting with any of those either. And so we were like, oh, this is pretty interesting. And it had these features of the jaw that sort of showed, so it's quite a muscular jaw. It had features that showed it was maybe related to more basal kangaroos, so, something that evolved a little earlier, an older lineage, we might say. So we popped it in its own new genus, which we creatively also called Nombi. Put it in an evolutionary phylogenetic analysis, and basically found that while obviously just with two jaws, that's not heaps to go off. It seems to suggest that Nombi was quite a basal kangaroo and an early lineage of kangaroo.
It shows really how science works sometimes. Even someone like Tim Flannery, he produces this work, which obviously stands for a while, and then somebody new comes along and does a bit of reinterpretation. I think that's really important to understand for people, how science, is a process of testing and retesting these ideas.
Yeah, absolutely. And Tim's he's followed, all of these like strands of research and done all this amazing work over the years. And you can sort of see why he couldn't come back to work on little Nombi. But it's been nice because he was actually one of the reviewers on the paper. So sort of, got to have his thoughts and his input as we were sort of readdressing, some of his early work.
Did you get to come up with the name?
So that was basically, a couple of months of sort of it bouncing around in the back of heads. Had lots of different ideas, sort of names, I guess, talk about like the funny curve in the crest of its teeth and things like that, or maybe its kind of robustness. But they're all sort of features that, we're not sure they'll necessarily define the genus. Should we find other species, for example, or, would be such an important feature of the kangaroo as a whole, if you know what I mean, when we're just sort of talking about teeth and jaws. So basically there wasn't a lot to go off of the name, for naming it. And we thought that Nombi, memorable, has a ring to it, very simple, just went with that.
Yeah,
So,
right.
yeah, I suggested it to Gav, thinking he'd say it was silly, and he said it was good. Sorry, Gav's my supervisor, I should say. He's
and co-author on the paper that we're referring to. Yeah, absolutely.
That's right, yeah.
Brilliant. That's fantastic. Really interesting work. What implications do you think this has for the way we understand kangaroo evolution across the continent?
I mean, it's a fairly small paper, so I'd say the implications are maybe gentle. But yeah, essentially it suggests that, particularly in New Guinea, where this is from, it suggests that the Macropodidae there, the kangaroos from there, are a bit more diverse than we thought. For a while, there was sort of the question why, I should say, the megafaunal, the marsupial megafaunal array in New Guinea it's quite sparse compared to Australia. So we have just the diprotodontids, the giant quadrupedal herbivores, just a few species from there, I think 3. And then from the Pliocene and Pleistocene, the kangaroos we have, I think, off the top of my head, maybe 6 species. And then there's Thylacines, and I think that's it for what we might consider giant marsupials. So that's 3 marsupial families. And then in Australia, I think there's, just in the Pleistocene, there's at least 8. And as we discussed, they were connected, for quite a period of time. And so why that isn't really apparent, why there are so few megafaunal marsupials in New Guinea. But this basically suggests that there was this greater level of diversity, and that there were sort of possibly multiple movements of megafaunal marsupials into New Guinea, rather than just sort of one, early in the Pliocene. There might have been more significant more significant ones earlier. And it also just basically shows that, we don't know everything about, what kangaroos are and what they were well into when, humans were in Australia.
Fantastic. Is there anything else we need to know about Nombi Nombi?
Not yet. Just watch this space. Hopefully, we're going back into New Guinea. Very exciting. Starting in the middle of next year, and then again for 2 more trips in consecutive years. Hopefully we find more bones, maybe even a complete skeleton, and we get to tell everyone what it actually looks like. We've had a pleasant amount of media interest in this topic. Friends I haven't seen for a very long time saying, "Oh, I read your article," whatever. That's been very nice. So hopefully we get to show you what it looks like in a couple of years' time.
Fantastic. We will link both the full published article and also your conversation piece in the show notes as well, so anyone who wants to follow up can find out more information. Isaac Kerr, thank you very much for joining Fossils and Fiction. Thanks to Adele and Isaac for taking the time to tell us about their work. It's fantastic to see such interesting and exciting work emerging from young Australian scientists. Full details of the papers we discussed will be in the show notes. Thank you for listening to the Fossils and Fiction podcast, produced by me, Travis Holland, with the support of Charles Sturt University. The podcast theme music is Sonora by Quincas Morea via the YouTube audio library. Find more content on our social media channels: Twitter, Facebook, YouTube, Instagram, and TikTok. Show notes are available on the website fossilsfiction.co. You can subscribe to the podcast on all major podcasting platforms.